in the first step, the SDX50, for example, is a chipset that goes on the side, and then integration comes after that. Okay, thanks. I'm going to introduce our next speaker, Dr. John Smee, and he's one of our really good guys. He's been at the company, I think, since 2000, and he is the leader of our 5G R&D program. So I'd like to welcome Dr. John Smee.
Well, great. Thanks very much for the introduction, and it's certainly my pleasure to go in a little more detail on some of the technical design aspects and give you a flavor also for kind of how our team operates, and as Matt mentioned, across prototyping, design, and standardization. One of the kind of hallmarks of Qualcomm's operating model is that we really have the same people multiplexing across a variety of roles. And so we'll literally have someone get off the plane from a standards meeting and immediately be discussing with our product team some of the latest design decisions in 3GPP and how that can impact our roadmap. And so it's kind of an exciting time, particularly in 5G, as we're moving through this study item into the work item. And so one thing I wanted to kind of point out at the beginning here also was, just as we acknowledged when we started 4G, we kind of had a clear game plan of making basically a better mobile broadband system. But it wasn't really about new use cases. And so one of the challenges of 5G is we began our research program and we're questioning ourselves, hey, what is different? What makes 5G relative to, as we're saying, 4G Advanced Pro? Where is the actual differentiation? And so that underscored a lot of our technical analysis and design decisions that we're focusing on doing these different use cases, but at the same time being optimized for each of the different use cases. So we didn't want to boil the ocean and have an incredibly complicated system that became a paper spec and wasn't really practical. So it was really about allowing special casing, but doing it from a broader framework. And in particular, the aspects I wanted to highlight was the aspect of deployments. So we're really obviously moved from a macro cellular-based world to a much more heterogeneous network. There's some questions on, hey, what about Wi-Fi style, pure decentralized approaches versus more centralized approaches. So we're in an era now, obviously, of the benefits of Cloud RAN, in addition to the benefits of smaller cells. So aspects of remote radio heads, how can we efficiently support these different topologies? And as my next speaker, Mingzi Fan, will also speak to the key role of spectrum and moving into shared spectrum paradigms. So it's no longer a pure world of only having licensed spectrum for operators, but rather a much more complicated opportunities in different markets, in different bands, and with much more sophisticated approaches of how we can do that sharing. So one of the goals of the 5G overall ecosystem is to open up the bands. And then I'll also talk a little bit about the services and devices, the fact that we're not just trying to serve the smartphone. As Matt said, the key point is that where does the opportunity increase in 5G? Sure, we're going to have better chips for smartphones and deliver improvements there, but it is the fact that there's a much more heavy engagement across all these industries. So if we look at, okay, where are we at in general from the design standpoint, as we mentioned, we're moving through the Release 14 study item that's actually wrapping up, and the decisions that are made as part of that study item